Okay, section 3, conservation of energy. What is the law of the conservation of energy? Energy cannot be created or destroyed. 1 mark. Total input energy is equal to total output energy. That's nice and easy. Next one, it says an object is raised into the ground, into the air. It gains 4,500. I don't need to change you of GPE. The mass of the person is 55. I don't need to change you. You're in kilograms. What's the height? So we know GPE equals mgh, or I could write it like this: mgh on the bottom, GPE on the top, and it says what is the height? So I need to work out h, and we can see h equals GPE divided by mg, and then we just got to pull the numbers down. So h equals GPE divided by mg, so there's my GPE, 4,500, divided by 55 is my mass, and you've got to know that gravity is 10, equals 8.2 meters. Okay, next one. Water within a dam gains 1.2 kilojoules. Okay, got to change that. Times 1,000, 1,200 joules. This drops through a water generator and transfers 850 as useful. So we know total input equals the useful plus the wasted. That has to be the case. So it says, what is the value of the wasted? Well, I've just got to take the 850 from the 1,200. So wasted equals the total, take away the useful. We've got 350 joules, just take them away. It says, what and where is the wasted energy transferred to? So anything, we've got water flooding through something that's spinning around, we're going to have lots of friction. Lots of friction will create lots of thermal energy, and that's then going to go into the air. And my favourite word is dissipated. So here comes your model answer. Thermal energy from friction is dissipated into the air. And that word, that little sentence, dissipated in the air, you'll need loads for your exam. Learn it, it's worth it. Next one, what's the efficiency of the motor? And we've got some numbers there. So efficient, useful tools, useful output, total input. A motor transfers 520 joules, I'm happy with you, to 0.12 kilojoules. So times 1,000, that's 120 joules. Now they're speaking to each other, they're both in joules. And this is wasted. It says, what's the efficiency? Well, I need to work out the useful first. So I'm going to have to take those two numbers away to get useful. So if you imagine it, I'll start with 520. 120 of it was wasted. The rest is useful. So that must be 400. So take those away and we've got 400 joules. Now I've got the useful, 400. And we can see the efficiency is the useful 400 divided by the total input equals 0.77. If it wants it as a percentage, times it by 100, that's 77%. Next one, an object has 1,200 joules of energy. Perfect, that's what I want you to be. The mass is 5 kilograms. Perfect, you're what I want you to be. Calculate the maximum velocity using v squared equals 2 lots of ke times m. Well, it wants the velocity, not velocity squared. So the first job is we're going to square root both sides, because that'll get rid of that square and that'll give me that. So our first job is, well, v equals the square root of 2ke over m. Now let's pull the values in. So I need 2 lots of 1,200 divided by 5. Well, that means I need the square root of 480, put it in a calculator, and I want the velocity, 21.9 meters per second. But the crucial part is to rearrange this. I just need to square root that side, and that'll get rid of that square. So v equals the square root of 2ke over m. Learn it well. And that's that section done.